Uh, my license just expired for this Zoom. So it's going to give us 40 minutes at a time. So we go 40 minutes. If it knocks us out, we can go back to finish up the thing, right?
Okay.
Yeah, so I'm not in limits as yet, but I took some question. I did put some question. I did place some theories. Yeah. All right. Yeah. So because I took from your own textbook, it's basically Thomas. I saw you using Thomas, so it's fine.
Yes, Thomas calculus.
Yeah, Thomas.
Yeah.
Yeah, Thomas calculus. All right. So here we go. Now, what we need to understand here, we are going to explain, it's basically two words. One of them is average, and then the other one is going to be instantaneous. Now, the average, normally, they must give you 2 points. Let me write 2 points. Every time, you must have 2 points or 2x values, so to speak. 2 points. If you're dealing with a two-dimensional, like Cartesian plane, the x and y, some do x, y, z, but you're doing 2, I know. So that means I must know what is x subscript 1. I must also know what is my x2. 2 points must be given. Now, in place of x, they can use any letter. Sometimes they use time. It can be time t1, it can be also t2. Sometimes you can work with an H or whatever, but I'm going to limit it to X and time only at this point. So once you hear average, you are saying to yourself, I need 2X values or 2T values. You must give it to me.
Yeah.
They can call it average gradient. They can call it average speed, average distance, average flow, average cost, everything. Once it starts off with the word average, before you can finish the thought, just say, I need 2x values. All right.
Yeah.
Yeah. So the idea is this. Once you've got 2x values, let's say you've got x subscript 1, and then you also have x subscript 2, the second value. All you need to do, substitute x subscript 1 into the formula. So the formula must be given to you. Put it into the formula and get the corresponding y subscript 1, the y value, and also you do y2. We good, right?
Yes.
Remember you did gradient of a straight line.
Yeah.
That's what average is. When you do the gradient of a straight line, which is given by, we normally write it as delta y all over the delta x. And we know what that means. It means you must take y subscript 2 minus y subscript 1, and then you must divide that by x subscript 2 minus x subscript 1. Do you understand? You know that, am I right?
Yes.
All right. So if you use this equation to a straight line graph, you use that equation. We call it the gradient, not average. It is the gradient of a straight line.
Yeah.
But if you use it to any graph that is a curved one, not straight, that's why we're talking about slopes, gradient of a curve. All right, let me just bring back some other words here. We call it slope here. And remember, it's also called the gradient. All right, it's also called, we're going to call it the derivative later. Okay, for now, we're sticking with slope and gradient. If I use this formula, gradient of a straight line on the curve, it won't be the exact gradient. It will be the average gradient. Are we happy?
Yeah.
All right, now I'm going to give you another name. Another name for that average, when you've got 2 points, if you draw a straight line, like I told you, you must have 2x values. When you draw a straight line, your straight line will cut the curve at 2 points. As I've said, you need 2 points. That means a straight line intersects the graph at 2 points. And yes, that line that cuts the graph at 2 points, it is called a secant, you know, like cos, tangent.
Yes.
Yeah, that's what it is. That's what a secant is. It's actually, when you work out the gradient of a secant, it's what we call average gradient of a curve. Happy?
Okay.
So far so good, right?
Yes.
Yeah. So what I just said to you, I've said so much. What I just said to you, you need 2 points, x1, y1, x2, y2, and then you just substitute into that equation, and then you're done. Remember, they can hide your x. They might use it as t subscript 1. Your y could be something else. It could be f of t1, whatever it might be, but it is y1 and y2. Okay? Yeah, that's all you need to do. All right, so now look at that. Let me pass through. I'll come back to instantaneous. Let's look at that one. They gave you a little equation here, this equation. So they're telling you that equation is for distance. You can see that we don't need to read everything. I'll explain everything. It's for distance. So it's basically 16 t squared. So I'm going to make a distance. It's measured in feet. We could have just used meters here in South Africa because it's an American book. They're using feet. So now the question says here, because I think that there's an example. I've got questions here. So I'm going to jump here because that's what they were telling you. Average speed. I need 2 points. So let's look at an example. It says a rock breaks loose from the top of a tall cliff. What is the average? So I'm not, before I can even conclude the thought, they said average. I'm like, okay, 2 points are coming now. 2 points are coming to me. What is the average speed during the first, the keyword first 2 seconds? The first 2 seconds start from 0. You definitely start from 0. You go 0. Let's just go by intervals of 1, 0, 1, 2. So that means when I began when T1 was 0. Now I ended when T2 was 2. Is it making sense to you now?
Yes.
All right. So I'm going to change that. So the story is saying, hey, we are giving you the initial time. T1, it's actually 0. And then T2 is actually 2 seconds. So those T's, if you go back to that equation that has 16T, it's actually in the place of X, like how we know it mathematically most of the time. We're like, okay, yeah, that's your X. So that Y, can you see? We need to figure it out. So what I'm going to do, I need to take 0, put it in place of T. So that means I'm going to open the parentheses. I said, okay, when I've got 0, in other words, when T1 is 0, what will be the Y value that goes with it? So you just substitute it into that equation. So which means you're having 16 into 0 squared. Come on, we can tell it's going to be 0, isn't it?
Yes.
All right. And then I put 0 there. So that will be our Y1. And then we need to go for another one at T equals to 2. So when T is 2, and then the question is, what will be the Y? So basically, I know it must be 60 something. So we've got 16, open the bracket, substitute the 2, close the bracket, you square that, 64. There we go. That will be 64. Is it making sense up to this point?
Yes, it is.
Okay, good. So all you have to do is just to use that formula. Though they call it average gradient, it stands for different types of averages. So in this case, instead of calling it average gradient, we're going to call it average speed, because that's what they requested, average speed. So we can give them the answer. We can say, okay, guys, if you want speed, I'm just going to put a subscript AVE for average equals to, in my case, that means I need to take, remember, you start with the Y at the top, meaning Y2 minus Y1 over X2 minus X1. I think you can tell Y2 is 64, correct?
Yes.
All right. Then we minus with the Y1, which is 0 there. Then we go substitute 0 there. Then at the bottom, we're going to work with the X, which are really T1 and T2. So we start with T2, which is 2. So we're going to have 2 and then minus the 0. And whatever is in the black box, we just need to put it in a calculator and then we are done. Well, we can actually say it has to be 60. Let me shift it up a little bit because I think this thing is hiding. You can't see what's up there. Let's bring it above there. Yeah, there it is. So it's going to be 64 divided by 2. Can you see that, basically?
Yes.
Yeah, which is, I think, 32. Let's just see. Yeah, there we
Yes,
go.
it is.
Yeah, so then our answer is basically 32. Remember, at the top, you've got the Y. Go back and trace Y. There's Y. Y is measured in feet. That means at the top, it will be feet over. At the bottom, we had 2 minus 0, which was time. But time was in second. Normally, it's in second time. You can actually trace them. If they should tell you what's given is. Yeah, there it is there. T in seconds, where I'm pointing. That means per second. So now you've got your average speed between, I'm stressing that, between the 2 points, 0 and 2 seconds. Sharp, sharp.
Yes.
All right.